This is Algebra 2, Lesson 10.3, Normal Distributions. So the graph image that we're looking at is called a normal distribution. You should notice that it is symmetric. The left side and the right side are exactly the same distribution. What that is actually meaning is that the mean and the median and the mode are all right in the center. And as we move out from the center, we have less and less and less and less and less of our population. The first thing that pops into my mind that is normally distributed is height. You'll have a lot of people who have an average height, and as you move further and further and further from that average, from that middle value, you don't have that many super tall people, and you don't have that many super short people. But let's work with this distribution. I said the mean, the median, the mode always goes in the middle. We're going to put the mean in the middle here. And you should be able to see this Greek letter. It's called mu. And it looks like kind of M, but kind of U, and it's mu. That stands for mean. And then there is another Greek symbol. It looks like a little O with a tail. That is a lowercase sigma. And it is representing a standard deviation. So the mean is at the center, and then the distance from the mean to this first inflection point is one standard deviation. And it would be another standard deviation to the next, and another standard deviation to the next, and then the same thing moving backwards. This is creating regions that are very specific to normal distributions, and it's called the empirical rule, but it tells us that exactly 34% of the population is within one standard deviation less than the mean, and exactly 34% of the population is within one standard deviation higher than the mean. If we move to two standard deviations, there is 13.5% in this region and 13.5% in this region. Moving past 2 on either side, we have 2.35% of the population in that region and 2.35% in that region. And then our final regions called the tails, we have 0.15% in either region. If we add these all up, that's 100% of the distribution. If we add up just half of it, that's going to be 50% of the distribution. So we have, I think, one more thing, and that's the maximum point. So if we wanted to calculate the maximum point here, it's 1 divided by the standard deviation times the square root of 2 pi. And I'm putting that denominator in parentheses so that if you type it in your calculator in one step, your order of operations should work out fine. So with all that information, let's try to utilize a distribution to help us calculate. The chest measurements of 18-year-old male footballers are normally distributed with a mean of 95 and a standard deviation of 8. If I want to sketch the distribution, we always put the mean right in the center. Then we're going to use the standard deviation to help us scale the axis. Every time we move up to the next point and to the next point and to the next point, we're going to add whatever our standard distribution is, whatever our standard deviation is, we're going to add 8. So 95 plus 8 is 103, plus 8 is 111, plus 8 is 119. And we're going to use the same to go down. We're going to subtract 8, subtract 8, subtract 8. So that will bring us to 87, and then 79, and then 71. Now, if you are a much better artist than me, you should try to get this curvy shape that's going to end at the top and then be really symmetric and come back down. I generally don't do really well with symmetry. I see this is a little bit higher than this is. So if you're not super good with your curve, I'm not going to be very particular. You could just even do that as long as I can tell what fits in each of these regions. So we should have 34 in each of our center regions, 13.5 in our next regions, 235 would go here, and then we'd have 0.15 on the tails. Those percentages are the same for every single normal distribution. What changes are the values along the axis. The mean and the standard deviation are dependent on the situation, but those percentages are always the same. So with our distribution set up, we can determine what percentage of the population fits between specific values. So the first one says, what percent fall between 103 and 111? Well, here is 103 right here, and one is 111 right here. So this part of the distribution is exactly 13.5%. The next one says, what percent fall between 87 and 119? Well, here's 87, here's 119, and if I wanted that value, I would add everything between those boundary lines. So let me see if I can do this here. That will be 34 plus 34 plus 13.5 plus 2.35. It looks like 83.85% of the population falls in that green region. And the final one says 90 and 100. 90 would be about, what do you think, here? And 100 would be about here. So, I mean, it's definitely less than 68 because we don't have that full 34 region and that full 34 region. But we don't actually have enough information or enough skills to calculate this answer. That would require a use of integrals, and we haven't learned calculus yet. So we're going to stop and say that's not enough info. If the answer you're trying to find falls on values that are not on our axis, then we're going to say not enough info. We're not going to move forward with that. So if you're getting a bunch of not enough infos, it might mean your axis isn't set up correctly. Letter C, what is the maximum point of the distribution? We had the formula way up top. That was 1 over the standard deviation times the square root of 2 pi. I'm going to go back to my calculator here. That is 1 divided by, in parentheses, 8 times the square root of 2 pi. Close it once for the root, close it once for the denominator. If you forget to close those, the answer still comes out the same, but we are at 0.0499. Probably could have said 0.05, but I wanted to have a number rounded correctly. So if we had a y-axis on this graph, we would find then that the maximum point here is basically 0.05, and we would probably want to scale that to have 0.01, 0.02, 0.03, 0.04, 0.05 to see kind of how tall each of these are. This is related to our distributions from yesterday, where if you're trying to find the mean, then you'd want the middle point here with the height here, and the middle point here with the height here, and so on and so on. But that's it for the notes. Good luck on the exercises, and let me know if you have any questions.